All right, let's look at a sequence. All right, sequence is essentially ordered collection of numbers or items. All right, but here's the definition. All right, definition is any function whose domain is a set of natural numbers. All right, it actually doesn't have to be a set of natural numbers. It could include zero, so you could start from zero if you want. All right, but typically it's going to start from 1. All right, so here's an example. All right, so we can call sequence an. All right, so since we can think of it as a function or define it as a function, I'm going to call it f of n also. So f of n is equal to an. Right, it's defined by say this particular function here. All right, so you can actually list of elements here. So an, so we're gonna so n is going from 1 to infinity. So this is just a bunch of you know an. So a1, a2, a3, and so on, right? But according to this formula, so what would be a1 or f of 1? We plug in 1 here, so 1 for n, so it's going to be negative 1 over n. So it's going to be negative 1 over 1, sorry, right? If it's 2, so negative 1 squared is positive 1, so it's going to be just a positive 1/2. And if n is 3, it's going to be negative 1/3 and 1/4 and so on. So we have that, right? So this is just an ordered collection of numbers or items, right? So that's a sequence, right? But we can think of it as a function whose domain is a set of natural numbers. All right, let's look at a couple of major examples. First one is called the arithmetic sequence. All right, so the characteristics of our arithmetic sequence is that you start with a number, and every time you go to the next term, you add a fixed number, say d, right? So you add d to it, right? So once you get to n, so how many? So for a2, we add d, 1d to a1. To get a3, you get 2d's to get to a1. So if you want to find an is going to be a1 plus n minus 1d added to it. Right? So here's an example. Right? If you look at this given sequence here, right? So what would be the difference? So you have 1/2 is 2/4, and the difference between 2/4 and 11/4 is 9/4. So you are adding 9/4 to get there, right? So if you add the 9/4 to 11/4, so that's 20/4, which is same as 5. So you have adding 9/4, right? Then if you add, you know, 20/4 to 9/4, you get 29/4, right? So you can see that this is a arithmetic sequence, right? So we can have a formula. Formula for the nth term is going to be very first term, which is 1/2, plus n minus 1, and a d in this case is 9/4, right? So this is the formula for this particular arithmetic sequence. All right, the second example is a geometric sequence. Right, so instead of this time adding, you know, to go to the next term, we multiply by a fixed number r. So you multiply a fixed number r. Right? So by the time you get to an, how many times we need to multiply by you know, r? So you start with a1, then you multiply by r. You can see that the n minus 1 times, right? So here, next example here. it's a big number. All right, so to go to a 768 to negative 192, so it's got to be a negative number, so multiply by a negative number. All right, looks like, let's see, it's a quarter of a 768 at 192. So you multiply by 1/4, negative 1/4. So you can see that if you multiply negative 192 by negative 1/4, you get the positive 48. If you multiply 48 by negative 1/4, you get negative 12, and so on. So it just keeps on going. So we know exactly how to find AN. AN is going to be the A1, which is 768. R in this case is a negative 1/4, and raise it to the n minus 1. All right, so that's the formula for this particular geometric sequence. All right, that's it. I hope that this was clear.